Okay, so let us have this example about short columns that are subject to axial loads with uniaxial bending. Okay, so in this problem, we would be determining the design axial strength of a column with eccentricity of 350 mm and section properties as follows. So we have here your F prime C, 28 megapascal. We have here your yield stress of 276 megapascal, our AS and our AS prime with both 4 pieces 28 mm diameter rebars. B is equal to 400 mm, H is equal to 600 mm, and the distance from the concrete to the centroid of the longitudinal bars, that is to be equal to 75 mm. So basically, this is what it would look like. So if you are wondering, guys, so if this is to be B, and this is to be H, but why are they drawn in this manner? So isn't it the case that H should be vertical and B horizontal? So you can draw it that way. The only reason that I drew it this way is because that I like it this way. So if you want to draw it in a portrait orientation, then it would be up to you as long as we follow the same method. But disclaimer, guys, that this method that I will show you is not the only method in determining the strength or the design axial strength of a column with eccentricity. Okay, so moving forward, guys, if you have already watched the previous video, the first thing that we will be doing here is that we will be solving for E balance. So why will we solve for E balanced? That is for us to have a basis for our assumption. Because in these kinds of problems, we would be assuming the value for our C up until we will be satisfying this equation. So we have here your Mn, and this is to be equal to Pn times E. So we already have the value for your E. And for us to arrive at an answer of Mn and Pn, we would be assuming the value of C. So the correct value for C that would satisfy this equation would be, once again, the correct value of C. The answer of Mn and Pm as brought about by your assumption C is, of course, the value for your Mn and Pn. So without further ado, because ang tagal na ng introduction natin, so let us just solve for this problem. Okay, so let us first determine what the value of our effective depth D is. So our effective depth D, so by the way guys, so for your eccentricity, so if this is to be 600 mm and if you would be getting its centroid, so its centroid would now be approximately here, or let's say exactly at that part if my scaling is correct. So approximately it is this. Hindi ko ma-move pero yun na lang yan. And with that guys, this is now to be equal to 300 mm. And this is also equal to 300 mm. So 300 and 300. But the eccentricity is to be 350 mm. So what does that mean? So if this is to be 300 mm and 350 mm is to be located here, so I would just be drawing it with our blue ink. So let's say that this is to be our 350 mm. So this is to be our eccentricity. So eccentricity, 350 mm. So if you are wondering, if the load is to be in this location, so if I am to draw it like this, so let's say that this is to be your column, and this is to be its centroid. Sorry, this is to be its centroid. And this is now to be equal to 300 mm. And this is also 300 mm. But the eccentricity is to be 350 mm. So what that means is that your load is acting here. So suppose that this is now to be equal to 350 mm. So if you are wondering, is this even possible? So if this is to be your load, Pn, will this just fall down? As you can see here, because it is not directly at this portion. So good observation if you thought of it that way, but it is to be the wrong theory or the wrong logic. Because this eccentricity, so this eccentricity is only concerned with, of course, the combination of your Pn and your moment. So what I mean here is that if I am to copy this to our next slide, so for a moment. So as you can see, we have a PPN here, a PN here at this location. So we have a Pn here and an eccentricity here. This is basically equal to, so I would just be copying this section for a moment. So if this is now to be your value for your Pn, so Pn, let's say, is to be acting concentrically. So when I say concentrically, it is to be located at the centroid. And there, and what else? So if this is once again the center line here, and we would be having a certain moment here. Sorry. So let's say there is to be a certain moment here. So moment, Mn. Okay. So the effect of this is basically the same if you would be combining the effects of this. So in this case, we have just separated their Pn and the Mn, but its effect, if they are to be under one loading condition, or let's say if they would be acting together, so your Pn and your Vmn, so let's say that I will be putting this here. So if I am to be combining the two, it would result to this. So parehas lang yan. So moment, so this is to be your moment, this is to be your Pn, and this is to be your Pn, and Pn times E is to be equal to Mn. So ayun guys. So if you would be seeing this is actually possible even though that is this 350 is not acting at the column already. So indication lang yan is that you have a moment that is, well, very big. So mas malaki yung moment natin kasi mas malaki yung yung eccentricity natin. But once again guys, if you would be seeing this, it is actually just the combination of your Pn and your Mn. So if I am to delete this, so ganyan siya. So once again, they would have the same result. Okay, so moving forward, so let us now solve for what needs to be solved. So what is now to be the value for your, let's say, effective depth D? Okay, so what is to be the effective depth D? So the effective depth D is the distance from your extreme compression fiber, or let's say that is the outermost compression fiber, up until the centroid of your steel rebars. And that is now to be equal to, so 600 mm, minus, so it is said here that the distance from the concrete to the centroid of the longitudinal bars, that is to be equal to 75 mm. So with that, we would just be subtracting 75 mm here. So if you are wondering, guys, isn't it, we must first subtract the concrete cover, the diameter of the shear reinforcement, and the centroid of the, what you call this, and the centroid of the longitudinal bars. So, truth be told, that is correct. However, it is already incorporated here. So, kasama na siya sa 75. So, your concrete cover, your shear diameter, and etc. is already included here. So, with that, RD is now to be equal to 525 mm. So, let me just confirm. So, looking at the calculator to your left. So, 600 minus 75, correct, 525. Okay, so what about for our AS and our AS prime? So I would just be writing them here so that I wouldn't be resolving them for every assumption that we will be doing later. So for our AS, so basically our AS is equal to our AS prime because both of them have 4 pieces of 28 mm diameter rebar. So with that, that is now to be equal to 4 times pi over 4 times the diameter squared. That is to be 28 squared. So looking at the calculator to your left, that is to be equal to, so 4 times pi divided by 4 times 28 squared. And that is now to be equal to 2463.00864. So you can write it this way. And in my case, I want to write it in this manner so that I wouldn't be I wouldn't be thinking about rounding it up or down anymore. So with that, guys, this is now to be 784 pi. So once again, if you want to write the decimal counterpart of it, up to you. Okay, so same is true as with this, since they have the same number of rebars in the diameter, so 784 pi. So there, so that is to be our AS and our AS prime respectively. Okay, so before assuming, let us check first our criteria for checking, or our criteria for our assumptions. So if you can remember before or in the previous video, if RE is to be greater than E balanced, then RC is to be less than C balanced. And for RE less than E balanced, then RC is now to be greater than C balanced. So let us now solve for the E balanced or the balanced eccentricity. So for E balanced, we must solve for CB first. So for the process, so I would just be writing them here. So for EB, or let's say E subscript B, we must solve for CB first. So number one, solve for CB. Then after solving for CB, solve for Fs prime. Then after solving for Fs prime, solve for the balanced axial strength. And then the balanced moment strength. Then after determining both of this, you will now be solving for the eccentricity by M and B divided by divided by P and B. Okay, so with that, guys, so for the value for our CB, so let us now solve for CB. So CB is basically equal to 600 divided by 600 plus Fy times D. So substituting known values, our Fy is to be 276 and our depth D is to be equal to 525. So looking at the calculator to your left, so 600 divided by 600 plus Fy times 525. So our C balance is now to be equal to 359.589 millimeters. So do not forget about this. So this is to be our C balanced. Okay, so before proceeding with the solution for your P and B and your M and B, let us first check if your compression rebars would yield, because we are already sure that your tension bars would yield because this is to be the balanced condition. But let us check if your compression bars would yield. So with that, so for your Fs prime, this is basically equal to 600 times CB minus D prime. So I will just be writing C minus D prime divided by C. So with that, looking at the calculator once again, so 600 times C, what is to be the value for our C? That is to be our C balance. So 359.589. I'm sorry, 589 minus D prime. And what is to be our D prime? So that is to be the distance from your extreme compression fiber, which is to be located here, up until the centroid of your of your AS. And that is to be 75 also. Okay, so minus 75 divided by C, and that is to be 359.589. And our Fs prime is now to be equal to 474.86. And since it is to be greater than Fy, so 276, it means that the Fy that we will be using is to be equal to 276 megapascal already. Because once again, you cannot go beyond Fy. So there, so our Fs prime, I should say. So our Fs prime is to be equal to 276 megapascal. Okay, so do not forget about this and this. So I will just be copying our CB here first. Okay. And our Fs prime be equal to 276 megapascal. And so we will now be solving for P and B, or the nominal axial stress. So if this is to be its stress diagram, so you have here your by the way, guys, in this sample here, in this figure here, of course you have your tension strength here, you have your compression steel here, and of course your concrete. So there. So this is basically ASFY. since we are already sure that it would yield. And this is now to be equal to AS prime, FS prime, but our FS prime is also equal to FY. So with that, we can write this as as Fy. And this is now to be equal to 0.85 times Fc prime times A times B. So for the value for your A, that is basically equal to betas of 1. So by the way, this is to be A balanced. Betas of 1 times C balanced. And our betas of 1 is to be, so betas of 1 is to be equal to 0.85 since F prime C is to be equal to 28 megapascal. So for every concrete strength that is to be 28 megapascals and below, your betas of 1 is to be automatically 0.85. I'm sorry, 0.85. So with that, this is now to be equal to 0.85 times 359.589. So our A balanced, is to be equal to, so looking at the calculator once again, so 0.85 times 359.599. Answer here is to be 305.65. Oops, 589 I should say. Wait. 589. So that is to be 305.6507 millimeters. Okay, so that is to be for your A. So for your P, so this is, let's say that this is now to be your P and B. So this is now to be P and B. So for your P and B, getting the summation of forces vertical, so you can do it this way. Summation forces vertical is equal to 0. Let's say upward positive. So just take all of this. Or you can also say summation of forces vertical equal to P and B. But of course, if that is to be the case, the other side of the equation, do not include this already. But to avoid confusion, let us just use of this way. Okay, so let's go from left to right. So for this, so 0 is to be equal to, so what is to be ASFY? ASFY. So for our AS, that is to be 784 pi. So 784 pi. Oh, by the way, I would just be writing them first. So AS Fy, but take note that this is negative since it is going downward. So going downward there. And for your P and B, so that is to be minus P and B also. And as for these two, so plus AS prime Fy plus 0.85 FC prime AB. So transposing this to the other side, so it would now look like this. So P and B would go here. And of course, the negative sign would now be removed. Okay, so substituting known values, so your P and B is to be equal to, so what is to be the value for our AS? So that is to be 784 pi. So negative 784 pi times Fy, that is to be 276. Plus, so this is also equal to 784 pi times 276. So coincidentally, they are the same, so they would just cancel out. Plus 0.85 Fc prime, and what is to be our Fc prime? That is to be 28. Times A, and our A balance is to be 305.6507 times B. So the value for our B is to be 400, I think. So going back here. So yes, 400 mm. Okay. So moving forward, so 400 mm. Okay, so with that, the value for our P and B, or the nominal balance axial strength here, is to be, so 0.85 times 28 times 305.6507 times 400. Then our answer here is to be 2909794. So 2909.664. So this is to be in terms of newtons. And if you want to convert it into kilonewtons, just divide this by 1000. Okay. So once again, our goal is for us to solve for the value for our E balance. So the next thing that we will be doing is that we will now be solving for the nominal moment or the balanced moment. So I will just be copying this. So I will be removing this first. Okay, so what about for our balanced moment? So for our balanced moment, what we would be doing is that we will be getting the moment about the center line. So there, and if for pretend that this is now to be our center line, so this is now to be equal to 300 mm, and this is also equal to 300 mm. So 300 and 300. And for this lever arm, for the lever arm for this ASFY, h over 2 minus d prime or the cover here, minus 75. So if this is to be depth, we would be subtracting h over 2. So with that, so this is now to be d minus h over 2. So both of these should have the same answer. Okay, so with that, our d is once again equal to 525. So minus h over 2, that is to be 300. And our answer here is to be 225. And as well as for this distance. So this distance is to be equal to, so this is to be h over 2 minus 75, since this is to be the d prime. So 600 divided by 2 minus 75, that should also be equal to 225, I should say, sorry. So 225 millimeters. Okay, and as for your value here, since the resultant of this compression block is to be located at the centroid of that compression block, so your lever arm here would now be equal to, so h over 2, which is 300, so h over 2 minus a. So if this is to be a divided by 2 is basically equal to a divided by 2. Okay, so there. So basically, so that is basically it. So hindi ko na muna i-substitute, so I wouldn't be substituting the value of a here for us to have a general equation that we can use later on. Okay, so moving forward, so with that, we can now get the moment about this point. So let's get the moment about this point. And as you can see, if we would be getting the moment about this point, all of these forces would result to a counterclockwise moment. So with that, all of them should be positive. So the summation of moment about the center line, that should be equal to M and B, or the balanced moment. And this is once again equal to, so let us go from left to right once again. So ASFY, so ASFY times what is to be our lever arm, that is to be 225. So 225. So plus, so let's go to the compression block. So that is to be equal to, so 0.85 FC prime AB. And of course, times the lever arm, and the lever arm here is to be this, h over 2 minus a over 2. So h over 2 minus a over 2. So there, plus what is to be the moment induced by this, so that is now to be equal to AS Fs prime, which is basically Fy in this case, times our lever arm of 225. Okay, so with that, substituting all known values, so for our M and B, that is now to be equal to ASFY. So what is to be our AS once again? That is to be 784 pi. So 784 pi times 276 times 225 plus 0.85 times what is to be our FC prime, that is to be 28. And for our A, so what is to be our A? So A balance is to be 305.6507. So 305.6507 times B of 400 times H over 2. What is to be our H over 2? That is to be 300. Minus A over 2, which is to be 305.6507 divided by 2. Since we do not have any space, let's proceed to the next line. So plus, so by the way guys, this is plus. So plus ASFY, and our AS is now to be equal to 784 pi. For Fy, 276. And for our lever arm, that is also 225. Okay, so substituting, solving for this equation using the calculator on your right, on your left, I should say. So that is to be 784. So my answer here is to be 734.153684.4 Newton millimeters. So this is to be the answer for your MNB. So what's next? So the next thing that we will be solving is for the value for your EB, or the balance eccentricity. So once again, our MN, so I would just be copying our answer. So our MNB is to be 734.15. And for our PNB, that is to be 2909.794. So for us to know the value for our EB, so EB is to be equal to MNB divided by PNB. So using these answers, this is now to be equal to, so looking at the calculator to your left, so answer, so this is to be my last answer, which is to be MNB divided by 2909.794.664. So this is to be PNB. And my answer here is to be 252.304 millimeters. So this is to be the balanced eccentricity. So what that means is that is to be the eccentricity that would ensure, or that is to be the eccentricity that would result to an Fs. So Fs be equal to exactly Fy. So our balanced eccentricity is somewhere here. So it is to be 250. So EB. So with that, guys, since our E is to be greater than EB, or E balanced, so this is now to be our basis for assumption. So our Fs is automatically equal to Fy. And for our C, or the true value of C, is to be greater than CB. Okay, so with that, since our CB, what is to be our CB once again? So our CB is to be equal to 359.589. Our assumption should be greater than, should be less than. Oh yeah, correct. It should be less than CB. So, yun, ulitin nyo lang, baliktad guys, no? So, if your E is greater than EB, your assumption for C should be less than EB. So, it is to be the other way around. Okay, so with that, if our CB once again, so I would just be copying this. So, for our CB, if our CB is to be 359.589, it means that our assumption should be less than 359. So, there. Okay, so, so maybe let us assume that. So, assume, let's say C be equal to maybe, let's say 300. So, let us assume that C is equal to 300. So, if our C is equal to 300, we will now be solving for all of this. So we will be repeating this process. So let us solve for PNB. Let's solve for MNB. And let's check if this equation would now be satisfied, which is to be MN is equal to PNE. Okay, so sige, try natin. So if C is to be equal to 300, our Fs prime is to be equal to 600 times 300 minus D prime, so 75. So I would just be writing the equation here. So C minus D prime divided by C. So our answer here is now to be equal to, so looking at the calculator once again, so 600 times C, that is to be our assumed C, that is to be 300 minus 75 divided by 300. Then our answer here is 450 megapascal. And since it is to be greater than Fy, we would be using fs prime equal to fy. Okay, so let us now solve for our P and B. So I will just be copying this equation, by the way, guys. So I will just be copying this here. So take note of this. So what I would be doing is just that I would be substituting the values. So this for P and B. And for our M and B, I'll just be copying this once again. So here, so take note once again, this is for M and B. Okay, so for our P and B, this is now to be equal to, so for our AS, so I think it is better if I would just be storing it since I keep forgetting what our AS is. So our AS is to be 784 pi. So 784 times pi. And I will be storing this to A. Oops, sorry. Store A. Okay, anyway. So there, and by the way, guys, after assuming your value for your C, of course, solve for the value for your A. And A is basically equal to betas of 1C. And with that, so 300 times 0.85. So the value for A is now to be equal to 255. Okay, so what's next? So let us now solve for this. So negative ASFY. So by the way, guys, do not memorize this equation because this equation is case per case basis. So this equation may not be applicable to other problems, and it may be only, it may only be compatible with our problem right now. Okay, so once again, do not memorize this, and you don't actually need to memorize this as long as you know the aspect, or you know the main idea of what is happening in the stress diagram. Okay, so with that, this is to be negative A. So I would just be, what I did a while ago is that I stored A here for your ASFY. So times 276 plus, so since they are the same, so A times 276. So by the way, guys, this should be FS, not FY. Kaya lang FY yan kanina, it's because in your balance condition, it was shown that your FY, or it was shown that your FS prime yielded. Though it is to be same in this manner, so same naman sila na FY din, but I would just be writing FS here for you not to get confused later on if ever we will be assuming for a section that would give an FS not equal to Fy. Okay, so anyway, so plus 0.85 times Fc prime times 28 times A, and that is to be 255, times B, that is to be 400. So with that, oh, by the way, guys, this is not PNB already, so this is PN. Since this is not a balanced condition already, any longer. So PN is to be equal to, so negative alpha A times 276 plus alpha A times 276 plus 0.85 times 28 times 255 times 400. So our answer here is to be 2427600. So 2427600. So this is to be in terms of Newton. So I would be maybe storing this to X. So shift store X. So there. So X. Okay, and as for our MN, so this is now to be A times 276 times 225 plus 0.85 Fc prime. This is now to be equal to 28. Okay, times A, and our A is to be 255. So times 255 times B, and our B is to be equal to 400 times H over 2. This is now to be equal to 300 minus A over 2. So minus 255 over 2. plus A Fy times, oops, by the way, Fy is to be 276 times 225. Okay. So, looking at the calculator to your left, so A times 276 times 225 plus 0.85 times 28 times 255 times 400 times 300 minus 255 over 2 plus alpha A times 276 times 225. So our answer here is now to be equal to 724. So Mn is equal to 724,666,673.1 Newton millimeter. So with that, I will be storing this to y. As to y, wala lang, gusto ko lang. So shift store y. Okay, so now let us check for E. So what is to be the value for your E? So for the value for your E, or let's say Mn, since Mn is to be equal to Pne, so for the value for your E, this is now to be equal to Mn divided by Pn. So with that, guys, so your Mn is, this was actually stored in Y, and this was actually stored in X. So with that, guys, this is now to be Y over X. Lapitan natin. So Y over X in my calculator. So with that, alpha Y and alpha X. So our eccentricity is to be 298.511. So the question, is our assumption correct? So as per given in the problem, our eccentricity is to be equal to, so where was that? Our eccentricity is to be equal to 350 mm. Okay, so as you can see that in our assumption, we have resulted to an eccentricity of 298, which is very far from 350 mm. So what we will be doing is that we will be assuming for another value for C up until we reach 350 mm. So with that, guys, since our value for E is to be less than 350 mm, what we will be doing here is that we will be decreasing our assumed C for our E to go up. So ganun yun, baliktad kasi siya, guys. So if you would be assuming for a value of C that is low, your resulting eccentricity would become high. So if you would be assuming a higher value for C, your resulting eccentricity would now go down. Okay, so if you are wondering right now already, is there a way that would give us, that would lead us straight, or that would lead us faster to our desired eccentricity other than assuming a random number? So actually, yes. This is what you are going to do right now. Okay, so after your first assumption, of course, you will now be solving for Mn first. So guys, copy ko lang muna to sandali sa next slide at baguhin natin yung steps. I-modify natin yung steps. Because once again, this is one step, and this is to be a step that would help you reach your desired eccentricity. So what we will be doing is that I will be deleting this first. So after that one, after knowing the value for your Fs prime, the next thing that you will be doing is that you will be getting, so you will be solving for Mn first. Okay, so after solving for your Mn, so ito guys, ito yung isang way para mas mabilis, pero optional to, but I advise you do the same. Okay, so after solving for the value for your Mn, and if you can remember, Mn is to be equal to E times Pn. So what you would be doing is that you would be solving for Pn using this equation. So with that, guys, so Mn is to be equal to Y. So as per stored here, so this is to be equal to E. So ngayon lagay natin yung gusto nating value ng E. So for our value of our E, 350 mm. So yan yung gusto nating makuha. So with that, this is now to be equal to 350 mm times Pn. So Pn is actually unknown because you have already solved for this Mn already. So with that, guys, no? So solving for Pn, so Pn is now to be equal to y divided by 350. So with that, so looking at the calculator to your left, so y divided by 350. That is now to be equal to 2070476.209 Newton. So this is now to be the value for your Pn. Okay, so what to do? So the next thing that you will be doing, so I will just be copying this to our next slide. So since this is to be the value for your Pn, you will now solve for C in this equation. So copy ko lang ulit. So we will now be using this equation for us to solve for the value for C. So instead of using A here, let us now use the value for C. So once again, instead of using A, let us So let us now use betas of 1C instead of A. So A, B. So this is now to be our new equation. Okay, so with that, let us now solve for C here since we already know the value of your Pn. So your Pn is to be this. So copy ko lang ulit. Pn is to be equal to, so negative A. So ito na-store ko ulit kanina, times 276 plus A times 276. So basically, guys, this would just cancel out because our Fs prime a while ago is to be greater than Fy. So with that, so plus 0.85 times Fc prime. So our Fc prime is now to be equal to 28 times betas of 1, that is to be 0.85 times C times B of 400. So with that, guys, solving for C, better yet if I would just be simplifying this equation for us to solve for C. So with that, guys, C is now to be equal to, so transposing everything to the other side. So Pn plus ASFy minus AS prime Fs prime. So guys, linipat ko lang to dun sa kabila. Divided by 0.85 times Fc prime or F prime C times betas of 1 times B. So you can do this. So pwede mong i-shift solve to, or you can do this directly. So I would just be doing this directly because I think we would be doing it a couple of times before we arrive at our answer. So with that, guys, so just looking at the calculator to your left, so C is now to be equal to, so Pn, so our Pn is to be 2070476.209 plus ASFy, so that is alpha A times 276 minus alpha A times 276 divided by 0.85 times Fc prime, so times 28 times beta 1, that is 0.85 times B, which is to be 400. So our value for C, as said in this problem, is to be equal to 255. So 255 point, oops, sorry, ayaw. So 255.867 millimeters. Okay, so ito daw yung gamitin nating C ngayon. So 25. So for a moment. Okay, so the next thing that we will be doing is that we will now be we will now be using this as our assumption in this problem. So paulit-ulit tayo dyan, cycle siya. So with that, guys, so I will now be erasing, sorry, ba't nawala? So I would now be erasing this. So instead of 300, I will now be using 255. So 255.867. So with that guys, so palitan na natin siya ngayon. So store ko lang to sa C, alpha C, para mas madali. And for your new value for your A, so bago na naman to. So 0.85, sorry. So 0.85 times 255.867. So that is now to be equal to 217.487. Or so ayan. Okay, so now let us now solve for the new value for our mn. So erase ko na itong lahat na to. So solve for the value for our mn. And this is now to be equal to, so substitute all known values. So by the way guys, before solving for mn, let us solve for fs prime first. So for your fs prime, so that is now to be equal to, so erase ko lang ulit to. So 600 times, so C, what is to be the value for your C? That is to be, well, alpha C minus D prime, so minus 75 divided by alpha C. Okay, so our answer here is to be 424. And it is to be, it is still greater than Fy. So with that guys, isolve nyo naman to ngayon, lahat ng to. So this is still Fs, by the way. This is still Fy, by the way. So with that, resolving for the value here. So A times 276 times 225 plus 0.85 times 28 times 217.487 times 400 times h over 2, so that is to be 300 minus a over 2, so 217.487 divided by 2 plus ASFY, so plus alpha A times 276 times 225. So our answer here is now to be equal to, so 701.8977 12.1 Newton millimeter. Okay, so the next thing that we will be doing is that we will now be solving for PN. So solve naman natin yung PN in terms of this. So ayun. So with that guys, I will just be storing this to y. So shift store y para same equation tayo dito. So with that, our new value for Pn is now to be equal to, so alpha y divided by 350. So that is to be 200,5422.035 newtons. Okay, so with that, let us now let us now solve for the value for your C. So ngayon palitan na natin to. Dito naman, so alisin na natin to. Let us change it with this value. So with that, so substituting this value to this equation na ginawa natin kanina, that is now to be equal to, so answer plus alpha A times 276 minus alpha A minus 276, times 276 divided by 0.85 times 28 times betas of 1, and our betas of 1 is to be equal to 0.85 times 400. So our answer here is now to be equal to, so 247. Okay, so 247.8278 millimeters. Okay, so our assumption here 247, our assumption here 255. So let us now try for another one. So makakailang iterations ka lang dyan, so paulit-ulit mong gagawin yan up until your assumption C is to be equal to your answer already. So that is to, this is to be a repetitive process up until, of course, your desired E. I mean, your desired C. Okay, so spoiler alert. After so many trials, so in my trials, the answer here is actually, so the correct assumption of C is to be 245.166 millimeters. So, what you would be doing is that you would be replacing this here in your assumption, then repeat the process, then you will be arriving at a new answer, then repeat the process, and ayun, after some time, I have arrived C is equal to 245.166, that if I would be substituting it here, so if I would be substituting it here, my C would be equal to 245.166. So ano ba ibig ko sabihin? So I think you are confused, but feel free to replay the video. So with that guys, if I am to replace this value for C, so assume C equal to 245.166. So calculator, nasa yung calculator ko? So my new value for A is now to be equal to, so 245.166 times 0.85. So this is now to be equal to, so 208.339 mm. So there, and as for your value for your Fs prime, so solve natin if it would still yield. So 600 times C minus D, so this is to be alpha, ano yung C natin? Wala pa pala. So 245.166 minus 75 divided by divided by 245.166. So our answer here is to be 416. So 416.45 mm, and it is still to be greater than Fy. So our Fs prime is to be equal to Fy. So substituting your A in this equation, so your A in this equation, so your new nominal moment is now to be equal to, so looking at the calculator to your left once again, so A times 276 times 225 plus 0.85 times 28 times A, and our A is to be 208.39 times B, which is 400, times H divided by 2, so 300, minus A over 2, so 208.39 divided by 2, plus alpha A times 276 times 225, and my answer here is to be 694,357. So 694,357,886.7 Newton millimeter. Okay, so with that, mapapalitan ulit ito. So solving for your P. So solving for P using mn divided by 350. So hindi ko na-store sa Y. So with that, answer divided by 350. So answer divided by 350, this is now to be equal to 1983879.676 newtons. So this is now to be this is now to be the value for your PN right now. So guys, do not memorize this 350. So this 350 mm right here was actually given in the problem. So this is our desired value for eccentricity E. Okay, so with that, I will now be copying this once again. So we will now be changing this PN by 198,3879.676. So resolving for C. So substituting this value to this equation, so this is now to be equal to, so answer plus ASFS. So A times 276 minus A times 276 divided by 0.85 times 28 times betas of 1, so that is to be 0.85 times B, which is 400. So our answer here is to be, so C is to be equal to 245.166 millimeters. So RC, our value for C here, is to be the same as with our assumption. Ito, as with our assumption. So meaning guys, that our value for Mn is indeed, our value for Mn is to be this, and our value for Pn is to be this. So ito na yung exact value natin ng Pn. So that is to be our nominal strength. And for our design strength, just multiply it by your phi. So teka, so if this is to be your Pn, so for our design strength, this is to be phi Pn. And since this is to be a tied column, our phi for tied columns is 0.65, if you can remember. So with that, phi Pn is now to be equal to, so just multiply this by phi, which is 0.65, so that is now to be equal to, so 1983879.676 times 0.65. So our design strength is to be 1289521.789 newtons. So this is to be our final answer.